When you think of the North Pole, it's hard to imagine that it could switch places with the South Pole. How would this affect our lives? Imagine that magnetic compasses start pointing in the opposite direction, maps need updating, and birds lose their ability to migrate. Is that possible? As it turns out, yes. Geomagnetic upheavals have happened in the past, and they involve changes that could be far more dangerous than they first appear. Let's understand this phenomenon and try to answer the main question: should we be worried? How does the Earth's magnetic field work? Where does our planet's magnetic field even come from? If you look at neighbors in the solar system, such as Mars and Venus, it becomes obvious that a magnetic field is not a guarantee for the planet. Earth owes its magnetic shield to a liquid outer core made up of iron and nickel. The movement of these materials creates electric currents, which in turn generate a magnetic field, an effect known as the geodynamo. Question to ponder: why does the Earth have such a stable magnetic field while other planets lack one? The magnetic field protects us from solar radiation that would damage DNA, cause mutations, and threaten life. Without it, Earth could face conditions similar to the surface of Mars, where cosmic radiation constantly attacks the soil. In addition, the magnetic field plays an important role in the formation of auroras, which are not only a beautiful natural phenomenon, but also an indicator of the Earth's interaction with the solar wind. However, this process is unstable. Our magnetic field is constantly vibrating, and the North Magnetic Pole is moving. Since 1831 it has moved 1,100 kilometers towards Siberia. Interestingly, the speed of this movement is increasing from 16 kilometers per year to 55 kilometers. The Earth, despite its stable processes, faces constant change. One of the key factors providing the magnetic field is the presence of a liquid outer core that interacts with a solid inner core. This dynamic creates a flow of electrically charged particles, which generates the magnetic field. What are geomagnetic flips? Geomagnetic flips are reversals of the north and south magnetic poles. Scientists have found that such events have occurred 183 times in the last 83 million years. Sometimes 40 million years pass between coups, and sometimes just a few 100,000. The last coup occurred 750,000 years ago, making us indebted to the new event. Why do such upheavals occur irregularly, and what causes them? The main hypothesis links the overturns to changes in motion in the Earth's core. These changes can be caused by processes in the mantle, by interactions between the outer and inner cores, or even by large external impacts, such as asteroid impacts. Modern satellite studies are helping scientists better understand the dynamics of these processes, although much remains a mystery. During a flip, the magnetic field becomes chaotic and its strength can drop by up to 10% of its current level. This temporary weakening raises many questions about how such changes might affect life on Earth. Scientists can track the overturns thanks to layers of magma that solidify with an iron orientation that indicates the direction of the magnetic field as they cool. These data show that overturns can be both short-lived and long-lasting. Potential consequences. At first glance, it appears that magnetic pole reversal is merely a geophysical phenomenon. However, weakening the magnetic field in the process can have significant consequences. Solar radiation. A weakened field will lead to increased radiation levels on the planet's surface, affecting human health and ecosystems. A weaker field will be less effective in reflecting the solar wind, which could cause DNA damage and an increase in cancer. Satellite problems. Satellites will be jeopardized by inadequate protection from solar particles. This will lead to failures in communications, navigation, and other technologies. For example, the South Atlantic anomaly is already posing risks to spacecraft flying over the region. Power grids. Power grids will become vulnerable to solar storms, which could cause global blackouts. Solar flares could short-circuit electrical systems and knock out large transformers. Climate change. Studies have linked temporary fluctuations in the magnetic field to climate change and mass extinctions. For example, in Australia 40 to 1,000 years ago, such an event could have led to the extinction of giant animals such as diprotodons and giant kangaroos. Is it possible that in the future humanity will be able to predict such upheavals and minimize their effects? Geomagnetic upheavals are an amazing example of how complex processes within our planet can affect all of humanity. Although the likelihood of catastrophic consequences is low, the weakening of the magnetic field raises questions about our preparedness for such changes. I believe we must continue to study this phenomenon, develop defense technologies, and be prepared for the possible consequences. Understanding magnetic upheavals is not just a scientific interest, but a key to our future. Do you think current technology will be able to meet the challenges that may arise in the event of another coup? The Earth's magnetic field is our protective shield against cosmic threats, and its dynamics play an important role in preserving life on the planet. Its unique structure and ability to self-repair make it one of the main reasons why the Earth remains habitable. From small field fluctuations to possible upheavals, it all reminds us how fragile life on our planet is. However, with our level of knowledge and technology, we are able to face the challenges that nature poses to us. Let's continue to explore the mysteries of magnetic fields to prepare ourselves for any changes that may occur. Don't forget to subscribe to our channel for more fascinating information about our planet and the cosmos.